Neolithic Europe is the period when Neolithic technology was present in Europe, roughly between 7000 BCE and c. 1700 BCE. The Neolithic overlaps the Mesolithic and Bronze Age periods in Europe as cultural changes moved from the southeast to northwest at about 1 kilometer per year. This is called Neolithic Expansion. The duration of the Neolithic varies from place to place, its end marked by the introduction of bronze implements. In southeast Europe it is approximately 4,000 years, while in northwest Europe it is just under 3,000 years. Basic cultural characteristics. Regardless of specific chronology, many European Neolithic groups share basic characteristics, such as living in small-scale, family-based communities, subsisting on domesticated plants and animals supplemented with the collection of wild plant foods and with hunting, and producing handmade pottery, that is, pottery made without the potter's wheel. Polished stone axes lie at the heart of the Neolithic culture, enabling forest clearance for agriculture and production of wood for dwellings, as well as fuel. There are also many differences, with some Neolithic communities in southeastern Europe living in heavily fortified settlements of 3,000–4,000 people, whereas Neolithic groups in Britain were small and highly mobile cattle herders. The details of the origin, chronology, social organization, subsistence practices and ideology of the peoples of Neolithic Europe are obtained from archaeology, and not historical records, since these people left none. Since the 1970s, population genetics has provided independent data on the population history of Neolithic Europe, including migration events and genetic relationships with peoples in South Asia. A further independent tool, linguistics, has contributed hypothetical reconstructions of early European languages and family trees with estimates of dating of splits, in particular theories on the relationship between speakers of Indo-European languages and Neolithic peoples. Some archaeologists believe that the expansion of Neolithic peoples from Southwest Asia into Europe, marking the eclipse of Mesolithic culture, coincided with the introduction of Indo-European speakers, whereas other archaeologists and many linguists believe the Indo-European languages were introduced from the Pontic-Caspian steppe during the succeeding Bronze Age. Archaeology. Archaeologists believe that food-producing societies first emerged in the Levantine region of Southwest Asia at the close of the Mini-Ice Age around 12,000 BCE, and developed into a number of regionally distinctive cultures by the 8th millennium BCE. Remains of food-producing societies in the Aegean have been carbon-dated to around 6500 BCE at Knossos, France, the cave, and a number of mainland sites in Thessaly. Neolithic groups appear soon afterwards in the Balkans and south-central Europe. The Neolithic cultures of southeastern Europe show some continuity with groups in Southwest Asia and Anatolia. Current evidence suggests that Neolithic material culture was introduced to Europe via Western Anatolia, and that similarities in cultures of North Africa and the Pontic steppes are due to diffusion out of Europe. All Neolithic sites in Europe contain ceramics, and contain the plants and animals domesticated in Southwest Asia: einkorn, emmer, barley, lentils, pigs, goats, sheep, and cattle. Genetic data suggest that no independent domestication of animals took place in Neolithic Europe, and that all domesticated animals were originally domesticated in Southwest Asia. The only domesticate not from Southwest Asia was broomcorn millet, domesticated in East Asia. The earliest evidence of cheese-making dates to 5500 BCE in Cthuljew, Poland. Archaeologists seem to agree that the culture of the early Neolithic is relatively homogeneous, compared both to the late Mesolithic and the later Neolithic. The diffusion across Europe, from the Aegean to Britain, took about 2,500 years. The Baltic region was penetrated a bit later, around 3500 BCE, and there was also a delay in settling the Pannonian plain. In general, colonization shows a saltatory pattern, as the Neolithic advanced from one patch of fertile alluvial soil to another, bypassing mountainous areas. Analysis of radiocarbon dates show clearly that Mesolithic and Neolithic populations lived side by side for as much as a millennium in many parts of Europe, especially in the Iberian Peninsula and along the Atlantic coast. With some exceptions, population levels rose rapidly at the beginning of the Neolithic until they reached the carrying capacity. This was followed by a population crash of enormous magnitude after 5000 BCE, with levels remaining low during the next 1,500 years. Populations began to rise after 3500 BCE, with further dips and rises occurring between 3000 and 2500 BCE but varying in date between regions. A study of 12 European regions found most experienced boom and bust patterns and suggested an endogenous, not climatic cause. Genetics. Archaeologists agree that the technologies associated with agriculture originated in the Levant, Near East, and then spread into Europe. However, debate exists whether this resulted from an active migratory process from the Near East, or merely due to cultural contact and trade between Europeans and Near Easterners. Currently, 3 models summarize the proposed pattern of spread. Replacement model posits that there was a significant migration of farmers from the Fertile Crescent into Europe. Given the technological advantages, they would have displaced or absorbed the less numerous hunter-gathering populace. Thus, modern Europeans are primarily descended from these Neolithic farmers. Cultural diffusion. In contrast, this model supposes that agriculture reached Europe by way of a flow of ideas and trade between the Mesolithic European population and Anatolian farmers. There was no net increase in migration during this process, and therefore, modern Europeans are descended from the original Paleolithic hunter-gatherers. Pioneer model recognizes that models 1 and 2 above may represent false dichotomies. This model postulates that there was an initial, small-scale migration of farmers from the Near East to certain regions of Europe. They might have enjoyed localized demographic expansions due to social advantages. The subsequent spread of farming technologies throughout the rest of Europe was then carried out by Mesolithic Europeans who acquired new skill through trade and cultural interaction. Genetic studies. Genetic studies have been utilized in the study of prehistoric population movements. On the whole, scientists agree that there is evidence for a migration during the Neolithic. However, they cannot agree on the extent of this movement. The conclusions of studies appear to be operator-dependent. That is, results vary depending on what underlying mutation rates are assumed, and conclusions are drawn from how the authors envisage the results fit with known archaeological and historic processes. Consequently, such studies must be interpreted with caution. Perhaps the first scholar to posit a large-scale Neolithic migration based on genetic evidence was Luigi Luca Cavalli Sforza. By applying principal component analysis to data from classical genetic markers, Cavalli Sforza discovered interesting clues about the genetic makeup of Europeans. Although being very genetically homogeneous, several patterns did exist. The most important one was a northwestern to southeast incline with a Near Eastern focus, accounting for 28% of the overall genetic diversity in the European samples in his study. He attributed the decline to the spread of agriculture from the Middle East Sea. 10,000 to 6,000 years ago. Cavalli-Sforza's explanation of demic diffusion stipulated that the declines were due to the population expansion of Neolithic farmers into a scarcely populated, hunter-gathering Europe with little initial admixture between agriculturalists and foragers. The predicted route for this spread would have been from Anatolia to Central Europe via the Balkans. However, given that the time depths of such patterns are not known, associating them with particular demographic events is usually speculative. Apart from a demic Neolithic migration, declines may also be compatible with other demographic scenarios, such as the initial Paleolithic expansion, the Mesolithic re-expansions, or later colonizations. Studies using direct DNA evidence have produced varying results. A notable proponent of Cavalli-Sforza's demic diffusion scenario is Chickie. In his 1998 study, utilizing polymorphic loci from 7 hypervariable autosomal DNA loci, an autocorrelation analysis produced a declinal pattern closely matching that in Cavalli-Sforza's study. He calculated that the separation times were no older than 10,000 years. The simplest interpretation of these results is that the current nuclear gene pool largely reflects the westward and northward expansion of a Neolithic group. Although the above studies propounded a significant Neolithic genetic contribution, they did not quantify the exact magnitude of the genetic contribution. Dupe and Loop performed an admixture analysis based on several autosomal loci, mtDNA and NRY haplogroup frequencies. The study was based on the assumption that Basques were modern representatives of Paleolithic hunter-gatherers gene pool, and Near Eastern peoples were a proxy population for Neolithic farmers. Subsequently, they used admixture analysis to estimate the likely components of the contemporary European gene pool contributed by the two parental populations, whose members hybridized at a certain moment in the past. The study suggested that the greatest Near Eastern admixture occurs in the Balkans and southern Italy, whilst it is least in peoples of the British Isles. The authors concluded that the Neolithic shift to agriculture entailed major population dispersal from the Near East. Results derived from analysis of the non-recombining portion of the Y chromosomes produced, at least initially, similar gradients to the classic demic diffusion hypothesis. Two significant studies were Semino 2000 and Rosser 2000, which identified haplogroups J2 and E1b1b as the putative genetic signatures of migrating Neolithic farmers from Anatolia, and therefore represent the Y chromosomal components of a Neolithic demic diffusion. This association was strengthened when King and Underhill found that there was a significant correlation between the distribution of HGJ2 and Neolithic painted pottery in European and Mediterranean sites. However, studies of the ancient Y DNA from the earlier Neolithic cave burials of Cardium pottery culture shows they were mainly haplogroup G2A. These Neolithic lineages accounted for 22% of the total European Y chromosome gene pool, and were predominantly found in Mediterranean regions of Europe. Y-DNA-based studies Later Y-DNA-based studies, exploiting an increased understanding of the phylogenetic relationships, performing micro-regional haplogroup frequency analysis, reveal a more complicated demographic history. The studies suggest that the large-scale clinal patterns of HGE and HGJ reflect a mosaic of numerous small-scale, more regional population movements, replacements, and subsequent expansions overlying previous ranges, rather than a single, large-scale wave of advance from the Near East. The apparent HGJ2 decline is produced by distinct populations movements emanating from different parts of the Aegean and Near East, over a period stretching from the Neolithic to the Classical period. Similarly, haplogroup E1b1b was also thought to have been introduced into the Balkans origins by Near Eastern agriculturalists. However, Cruciani et al. Recently discovered that the large majority of haplogroup E1b1b lineages in Europe are represented by the subclade E1b1b1A2V13, which is rare outside Europe. Cruciani, Battaglia and King all predict that V13 expanded from the Balkans. However, there has been no consensus as to exact timing of this expansion, nor as to where V13 actually arose. Overall, Y chromosome data seems to support the pioneer model, whereby heterogeneous groups of Neolithic farmers colonized selected areas of southern Europe via a primarily maritime route. Subsequent expansion of agriculture was facilitated by the adoption of its methods by indigenous Europeans, a process especially prominent in the Balkans. The data from mtDNA is also interesting. European mtDNA haplogroup frequencies show little, if any, geographic patterning, a result attributed to different molecular properties of mtDNA, as well as different migratory practices between females and males. The vast majority of mtDNA lineages have been dated to have emerged either in the Mesolithic or Paleolithic, whereas only 20% of mitochondrial lineages are Neolithic. However, this conclusion has been questioned. Any undetected heterogeneity in the founder population would result in an overestimation in the age of the current population's molecular age. If this is true, then Europe could have been populated far more recently, e.g. during the Neolithic, by a more diverse founding population. As Chickie states, we argue that many mitochondrial lineages whose origin has been traced back to the Paleolithic period probably reached Europe at a later time. However, Richards et al. Maintain these findings even when founding population heterogeneity is considered. In one such study, Wolfgang Hark extracted ancient mtDNA from what they present as early European farmers from the linear pottery culture in Central Europe. The bodies contained a 25% frequency of mtDNA-N1A, a haplogroup which they assumed to be linked to the Neolithic. Today the frequency of this haplogroup is a mere 0.2%. Hark presented this as supportive evidence for a Paleolithic European ancestry. Formerly there had been much debate about whether the westerly spread of agriculture from the Near East was driven by farmers actually migrating, or by the transfer of ideas and technologies to indigenous hunter-gatherers. A 2010 study of modern genetic diversity suggested that the lineage R1b1b2, like E1b1b lineages, spread together with farming from the Near East. Prior archaeological and metrological studies had arrived at similar conclusions in support of the migrationist model. By this model, 80% of European Y chromosomes descend from incoming farmers, and most mtDNA from hunter-gatherers. However, in 2011 a study has argued there to be serious flaws in the above proposed model, denouncing the perceived overgeneralization inherent in the studies of Balaresque 2010. Furthermore, Busby et al. 2012 point out, for this haplogroup to be so ubiquitous, the population carrying R1bs127 would have displaced most of the populations present in Western Europe after the Neolithic agricultural transition. Clearly common sense dictates that this did not happen. Also they go on to show that within the European-specific R1bm269 sublineage, defined by SNPS 127, there exists distinct subhaplogroups, and at this level there exists several geographically localized pockets, with individual R1bm269 subhaplogroups dominating dominating. The conclusions were that it is likely that R1 BS 127 was already present in native European populations and grew into several geographically distinct sublineages across Europe before Neolithic expansion occurred. In 2015, a thorough study by Hark al. about ancient DNA concluded, however, that both R1a and R1b very likely spread into Europe from the Pontic-Caspian steppe after 3000 BCE. There was a paucity of haplogroup R1b in European population samples predating the Bronze Age, with only one of the 70 individuals from Mesolithic and Neolithic Europe belonging to haplogroup R1. Among the analyzed male samples taken from Yamna culture sites, however, all possessed haplogroup R1b. Analysis of modern Europeans' autosomal DNA also gives support to a large population displacement from the steppe into Europe. A study of Neolithic skeletons in the Great Hungarian Plain in 2012 found a high frequency of Eastern Asian maternal haplogroups. Language. There is no direct evidence of the languages spoken in the Neolithic. Some proponents of paleolinguistics attempt to extend the methods of historical linguistics to the Stone Age, but this has little academic support, criticizing scenarios which envision for the Neolithic only a small number of language families spread over huge areas of Europe. Donald Rinch has argued on general principles of language geography, and the scanned remains of non-Indo-European languages attested in ancient inscriptions that Neolithic Europe must have been a place of great linguistic diversity, with many language families with no recoverable linguistic links to each other, much like Western North America prior to European colonization. Discussion of hypothetical languages spoken in the European Neolithic is divided into two topics: Indo-European languages and pre-Indo-European languages. Early Indo-European languages are usually assumed to have reached the Danubian Europe in the Chalcolithic or early Bronze Age, e.g., with the corded Warabica cultures. The Anatolian hypothesis postulates arrival of Indo-European languages with the early Neolithic. Old European hydronymy is taken by Hans Krahe to be the oldest reflection of the early presence of Indo-European in Europe. Theories of pre-Indo-European languages in Europe are built on scant evidence. The Basque language is the best candidate for a descendant of such a language, but since Basque is a language isolate, there is no comparative evidence to build upon. Theo Veneman nevertheless postulates a Vasconic family, which he supposes had coexisted with an Atlantic or Semitidic group. Another candidate is a Tyrrhenian family which would have given rise to Etruscan and Raretic in the Iron Age, and possibly also Aegean languages such as Minoan-Pelasgian in the Bronze Age. In the north, a similar scenario to Indo-European is thought to have occurred with Uralic languages expanding in from the east. In particular, while the Sami languages of the indigenous Sami people belong in the Uralic family, they show considerable substrate influence, thought to represent one or more extinct original languages. The Sami are estimated to have adopted a Uralic language less than 2,500 years ago. Some traces of indigenous languages of the Baltic area have been suspected in the Finnic languages as well, but these are much more modest. There are early loanwords from unidentified non-IE languages in other Uralic languages of Europe as well. List of cultures and sites. Mesolithic megalithic culture. Early Neolithic French The Cave, Greece. First European Neolithic site. Sesklo, Greece. Starchevo Chris culture. Dudeshti culture, Middle Neolithic Vinca culture, linear ceramic culture, circular ditches, Cardium pottery culture, Pitcomb ware culture, aka comb ceramic culture, pre-Cucuteni culture, Urtabol culture, Courtyard culture, Hembury culture, Windmill Hill culture, PFYN culture, Globular amphora culture, Horgan culture. Neolithic Cucuteni Tripillion culture, Langniel culture, a culture in Central Europe produced monumental arrangements of circular ditches between 4800 BCE and 4600 BCE. Varna culture, Funnelbeker culture, Baden culture, corded ware culture, aka battle axe, single grave culture, Gordo culture, Beaker culture, Stonehenge, Skara Brae, Megalithic. Some Neolithic cultures listed above are known for constructing megaliths. These occur primarily on the Atlantic coast of Europe, but there are also megaliths on western Mediterranean islands. C. 5000 BCE, constructions in Portugal, emergence of the Atlantic Neolithic period, the age of agriculture along the fertile shores of Europe, c. 4800 BCE, constructions in Brittany and Poitou, c. 4000 BCE, constructions in Brittany, Portugal, Spain, France, Corsica, England, Wales, Northern Ireland and elsewhere, c. 3700 BCE, constructions in Ireland, c. 3600 BCE, constructions in England and Malta, c. 3500 BCE, constructions in Spain, Ireland, France, northwest and central Italy, insular Italy, Malta, Belgium and Germany, c. 3400 BCE, constructions in Ireland, Netherlands, Germany, Sweden and Denmark, c. 3200 BCE, constructions in Malta, c. 3000 BCE, constructions in France, Spain, Belgium and Orkney, as well as the first henges in Britain, c. 2800 BCE, climax of the megalithic Funnelbeker culture in Denmark, and the construction of the henge at Stonehenge.